Today we're going to look at Unit 4, Matrices. So we talked a little bit about using a matrix to solve a system of equations with 3 variables. And so we worked on that on Thursday, I think it was, and then we practiced doing that in the calculator and going from there. Okay, and I told you that we would be looking at matrices next. So your I can statements or learning objectives today are I can identify matrices and their elements, and I can do addition, subtraction, and scalar multiplication with matrices. Okay, so today's work is pretty easy. Since this is the first time we're talking about matrices, we do have some vocabulary that we need to look at. We need to go over some things, but then your actual addition, subtraction, and multiplication or scalar multiplication is going to be pretty easy. So you're actually not going to have a ton of examples. I'm just going to kind of show you how things work with matrices, and then I'm pretty confident that you guys will find it easy. All right, so as usual, I'm going faster in the video than I would be in real life, so feel free to pause and rewind as you need to. We're going to start with some vocabulary. So first we just have matrix. A matrix is a rectangular arrangement of numbers written within brackets. And they're classified with a capital letter and their dimensions. And so I forgot to put the capital letter. So we can say that matrix A is this. So we have 3, 4, 1, 6, 2, 0. They're in brackets. Okay, and you notice these are the columns. Columns are vertical. There are 3 columns here. Rows are horizontal. There are 2. When you're talking about matrices, we usually talk about their dimensions. So you do rows, x, columns, so 2x3, because there are 2 rows, 3 columns, and we say that 2 by 3. So this is a 2 by 3 matrix because there are 2 rows and 3 columns, okay? You need to get familiar with that. You'll hear me say that a lot. So this is a 2 by 3, okay? And you're going to have to identify that. You're going to have to look at a matrix and decide how many rows and how many columns it is. And you're going to have to write that out. You're going to have to do the 2x3, okay? And it looks like 2 times 3. And so that might help you remember it. That's how you would figure out how many elements are in here. Okay, next we have a matrix element, and that's just each number in a matrix. And they're identified by their position in the matrix. So here we have our matrix A from before, the 3, 4, 1, 6, 2, 0. And so here is how we denote or identify an element. So we have a lowercase a, that means it's in matrix A, okay? And then we have a subscript. So we have sub 2, 1. So the 2 represents the row. So the first number is the row where it's located, and the second number is the column. So this tells me I'm going to look in matrix A, row 2, column 1. So matrix A, row 2, column 1. So that's a 6. So the number I was looking for is a 6. Okay, so element A sub 21 or sub 21 is 6. Okay, so here's some examples. So if I have A sub 11, so I'm going to matrix A, I'm going to row 1, column 1. So row 1, column 1 is 3. Okay, A sub 2, 3. So again, matrix A, row 2, column 3, that's 0. And then A sub 1, 3, so, or sub 13, matrix A, row 1, column 3. So that's 1. You will have to do that in your practice problems. Okay, and lastly, we have a square matrix. A square matrix means it has the same number of rows and same number of columns. Just like a square, all the sides are equal. So with a square matrix, the rows and columns are equal. So like 2 by 2, 3 by 3, 4 by 4, 5 by 5, so on. Or 1 by 1. I didn't add that in there. But as long as your rows and columns are the same, you have a square matrix. Okay, next we're going to look at addition and subtraction of matrices. So you can add and subtract matrices of equal dimensions. They have to be the same. So like here we have a 2 by 2 and a 2 by 2. And that happens to be the same example here. But you could not add like a 1 by 3 and a 3 by 2. Okay? They have to be the same dimensions, have the same number of rows and same number of columns. Because when you're doing addition and subtraction, you're just finding the corresponding elements and doing that operation. So I have 3 and 4. Those are in corresponding locations. So 3 plus 4 is 7. Okay. Then you can go however you want to. I like to go across. So -8 plus -1 is -9. And -5 plus 3 is -2. And then 1 and -7 is -6. Okay, so that's our answer. So I just took the corresponding elements. Our operation is addition, so I just added those together and got an answer. Now, you could do that in the calculator. I showed you that Desmos matrix calculator. You could do that in the calculator, but it's going to take you more time. It's going to be a lot easier for you to just do this addition in your head than it would be to type the whole matrix, all the matrices in the calculator and do the operation that way. Okay, so it's much quicker to just do the math. All right, so number 2, you have A equals this matrix, B equals this matrix, find A minus B. So we're just going to put those matrices in our expression. So we have 4, 8, 2, 0, minus 7, -9, 4, and 5. And we're just going to do that subtraction. So just like we did before. So 4 minus 7 is -3. 8 minus a -9, so minus a negative is positive, is 17. Then we have 2 minus 4 is -2. And then 0 minus 5 is -5. And so that rounds out that matrix. Okay, now I'm not going to do a bunch of addition and subtraction examples for you because I feel like it's pretty straightforward, and I think that you'll be fine with this. Okay, just match up the elements, make sure they're the same dimensions, match up the elements, and combine them using whichever operation you're told. Okay, next we're going to look at finding elements in a matrix. So we already talked about the different elements, how to find them. If you're given like A sub 11, you can go to the first row, first column. So we already know how to do that. We're going to translate that a little bit. We're going to find missing elements or missing pieces in the matrix. So here we have 2 matrices that are set equal to each other. So that means that this element is equal to that element, okay, and so on. And we're asked to find X, Y, and Z. So these 2 matrices are set equal to each other. So we know this first element is going to be equal to this one. So that gives us X equals -2. So that one's pretty straightforward. X is -2. We know 3 equals 3. That's true. Then down here we have 4y equals 12. So 4y equals 12. I divide by 4 and get y equals 3. So my y equals 3. And then last I have 8 equals z. So that one's also straightforward, just z equals 8. Okay, here's another example that's very similar. We just got a little bit more stuff to do. So here I'm given x plus 8 equals 38, and I want to find x. So I'm going to make it a little equation. X plus 8 equals 38. I subtract 8 from both sides and get x equals 30. So x equals 30. Okay, we know -5 is equal to -5, 3 is equal to 3. Then we're given -y equals 4y minus 10. So we can work that out. So set those equal to each other. -y equals 4y minus 10. We're just going to solve that. I can subtract 4y, get -5y equals -10, divide both sides by -5, and I get y equals 2. So we found x and we found y, and you're finished there. Okay, Next, we're going to look at scalar multiplication. Scalar multiplication is very much like the distributive property. It gives you the same kind of vibes. You're going to take the constant on the outside, you're going to multiply it to every element on the inside, and that gives you your new matrix. So 3 times 3 is 9, 3 times 5 is 15, 3 times 2 is 6, 3 times 8 is 24. And that's your new matrix. Okay? Same thing if you have a fraction. Half of -6 is -3. And I didn't leave myself a whole lot of room here, so I apologize that it's going to be tight. Half of 0 is 0. Half of -10 is -5. Half of 8 is 4. Half of 4 is 2. And half of -18 is -9. Okay? And then number 3, you're given A, you're given B, and it wants you to find 5A minus 3B. So we're combining operations here. We're going to have to do some multiplication, some scalar multiplication, and then subtraction. So just for example's sake, I'm going to write it all out. So 5 times A would look like this, minus 3 times B, okay? So 5 times A. So our new matrix is going to be 10, 15, -35, 5, 20, and 25. Now, you can do this a couple different ways. You can do it like the distributive property and multiply by a -3 and then just add. Or if you want to, you can leave the minus and just multiply by the 3. You can do it either way, but pick one. You can't like combine them. So I'm going to leave the minus in the middle. 3 times 3 is 9, 0, 18, -3, 24, and 6. Okay, so I just multiplied by the 3. I didn't use the negative. I left it down here. Okay, now we can do the subtraction. 10 minus 9 is 1. 15 minus 0 is 15. -35 minus 18 is -53. 5 minus -3 is 8. 20 minus 24 is -4. And 25 minus 6 is 19. Okay, and so there's your answer matrix. All right. And then just a couple little notes that I want you to make at the end here. For all of these that we've done in here, these are going to be the quickest by hand, okay? But you can use the desmos.com/matrix. You can use that calculator if you want to. We will actually look at it in the next lesson probably a little bit. But you're welcome to play around with that calculator with these problems if you want to, but just know it's going to be quicker for you to just do these by hand. If you have an addition, subtraction, or scalar multiplication matrix problem on the ACT, it's going to be quicker for you to just do the math, okay? And this is another thing, and we'll make a little note here too. We will learn how to do these with the TI Inspire calculators whenever we get them. Like when you come back in person, we can do these real quick together. Like we could learn it in just a few minutes. So we'll do that before the ACT. Okay. And so if we find out that we're not coming back to school for a while, or if you're taking the ACT, you're taking the ACT before we come back, if you want to see the calculator tricks, or you want to come in and see how to do the matrices in the Inspire calculators, you're welcome to do that at any time. Just let me know and you can come by and I'll show you how to do them. Okay. But like I said, we didn't do a whole lot of practice here because I think that it's pretty straightforward and you'll be able to do it on your own easily for the assignment. Okay. As always, I'm here if you need me. If you have questions, let me know. I'll be happy to assist you. Have a great rest of the day.